find the self energy of a solid sphere of mass capital M and radius r. So the first step is we say there is a general solid sphere of mass small m and radius x is over here. Now we'll start adding mass to it in differential elements of mass, and then we shall be finding what is the work which needs to be done in adding the differential mass onto this solid sphere. And once we find what is the work which needs to be done in adding this differential element of mass, that is very small mass, onto its surface, and then we will integrate it so that the radii it goes from 0 and eventually comes out to be equal to capital R. We'll integrate, we'll add all those works and we'll find the total work which needs to be done, and this total work gets stored as the potential energy or gravitational potential energy or self energy of this solid sphere. So we start with that there is a solid sphere of mass small m and its radius at this moment is x. Now what we do is we bring a differential element of mass, that is dm, from infinity, and we just spread this mass, sprinkle this mass over here onto this surface of this sphere. We bring this mass as a particle, or what we say is we bring this mass, differential element of mass, as a combination of very small particles, and we spread it onto its surface so that now we have an increased radius of this from x to x plus dx. That is, when we spread this mass, differential element of mass, uniformly onto the surface of this sphere, the thickness rises by dx. Then certainly this dm, if we talk about this dm, is what? Differential element of mass is what? It is volume into density. We know it is volume into density. Mass by volume is density, or density is equal to mass by volume. So this differential element of mass is what? Volume into density. What is volume? Volume is surface area into height into rho is going to once again dm only. Now what is surface area of this sphere at this instant is 4 pi x square. This is surface area into what is its height? Height is dx. So this is volume into density. Density is rho. We are taking the density of the material as rho. So this stands for the differential element of mass which has been brought from infinity and has been spread over this sphere uniformly to raise its thickness by dx. And also we know that is a work which needs to be done in bringing this body from here to here is differential element of mass is dm, that is mass, into the change in the gravitational potential. What is this gravitational potential difference? It is V2 is where? V2 is on the surface. Over here we are saying V2 because of this over here, and V1 over here, that is at infinity, because of this mass over here we are saying that is V1 is over here. And we know V, when we talk about the gravitational potential, it is minus gm upon r. Gravitational potential is minus gm upon r. So V2, when we say gravitational potential because of this mass m and radius x at this instant over here is going to be minus gm upon x. This is the gravitational potential over here, and because of this mass small m and radius x at infinity is going to be equal to 0. And what we have done is we have brought this mass dm, which is nothing but 4 pi x square, area into height volume into density. This is the dm. These are gravitational potentials which are established because of this mass. So it is minus gm by x over here at the position number 2. At position number 1 it is at infinity, so it is 0. So now dw is 4 pi x square dx into rho minus g m, we have put the value. Mass is equal to volume into density. Volume is what? 4 by 3 pi x cube. At this instant the mass of this is 4 by 3 pi x cube volume into density upon x comes over here. So its density remains same whether we take this portion or we take this portion, any arbitrary portion, or we take the whole mass. So density remains same. As we keep on adding this differential element of mass over its surface, its radius will be gradually be increasing, and finally it will attain radius equal to capital R and its mass will become capital M. So for that what we do is we do the integration of this whole thing, because this is a differential element of work which needs to be done in bringing our differential element mass from infinity and spread over this surface so that its radius increases by dx, and obviously eventually the mass also increases by dm. And if we integrate it, dw, and we take the limits, that is x is variable, x goes from first, initially it was 0, and then it keeps on rising as more and more mass is added up, and eventually it becomes mass becomes equal to capital M and radius becomes equal to capital R. So we take the limits x is equal to 0 to x is equal to capital R. When we integrate it, this comes out to be minus 3 by 5 gm square upon R. So minus 3 by 5 gm square upon R is the self energy or gravitational potential energy of a solid sphere of mass capital M and radius capital R, provided it has uniform mass density.